Hello. It's September 5th, 2023. It's a SIG Node weekly meeting. Welcome, everybody. We have a few items on agenda. Let's jump right into it. Paco, are you here for first item?
Oh, yes. This issue we have discussed in the issue, and currently we think this is a feature request, and for container level CPU static policy design. The current design is only about guaranteed pod, but in this case, if the sidecar or the other containers in the pod is not guaranteed, but one of the container is guaranteed and with integer CPU limit and request, should we do the same thing for those containers? So the current draft proposal is to add a new CPU policy, like container level static. Yeah.
I just want to jump in for a little bit, actually. Francesco and I were commenting on this issue, and I think one thing we can definitely evaluate is either a policy or policy option for this. But I would like to understand why splitting these pods into splitting these containers into separate pods is not an option. And I think the other concern I have is the implication around guarantees, because if you have a pod with a guaranteed container and a non-guaranteed container, the guarantee if you allocate exclusive CPUs to a guaranteed container, the expectation would be that that it's a workload that's consuming those CPUs, and it's, say, a performance sensitive workload or something really important that we want to keep for a long time. But because this particular pod is not going to have guaranteed quality of service, it could be evicted by another pod that has higher priority. So that's kind of the only concern I have. But I think in general, this could be a useful feature.
I think this also matches a recent request we got where, like, you have pod with two different kind of processes. Ones are always pinned, the other ones aren't running all the time. So if they assign CPUs for the ones that aren't running all the time, we are wasting resources. So we need a way where some are pinned and some processes aren't pinned. I think this kind of intersects with that kind of use case.
Yeah, absolutely. Actually, that's one of our team members who's working on that use case, and the use case is that one application is performance sensitive and the other one is maybe logging or something that's doing stuff in the background. So it makes sense. But I'm still not able to visualize how we will solve the overall priority problem in terms of quality of service of the pod.
Maybe we keep the whole pod guaranteed, like in the guaranteed class, even if a sidecar is not using full CPUs. That could be one way.
Is it specific to
potentially.
sidecars? Ronald, you mentioned that even worker pod can not need whole CPU reserved.
Yes. So we'll have to adjust the definition. I think we have a class of pods where you need some things that need full CPUs, but then they have helper processes that don't necessarily need full CPUs. So can guaranteed definition be expanded to include that? And we have some way, maybe they can be sidecars when they are not using full CPUs, you still stay guaranteed.
Yeah, I think if we can change the definition of guaranteed, I think it'll be okay. But I thought that's a very major change.
Or instead of relying on implicit definitions, create the explicit way to specify which container inside the pod which is which.
Yeah, so I think with sidecar, we have a way, right, to distinguish between the sidecar and the regular containers, Sasha. So are you suggesting yet another explicit marker for this case?
No, I'm just saying what, like, so far with CPU manager policy, we're like very relying very implicitly on QoS, on implicit QoS class of the pod. I'm saying what it might be time to think about explicit definitions inside the pod spec. What
Okay,
user
so
actually wants instead of assuming.
Yeah, can we have guaranteed with no request then, if we'll have explicit definition? Like, can the pod be guaranteed but have not requesting anything, or have no limits on anything?
I guess we'll still need to impose some rules, I guess, that admission, that it needs to have at least one container with this matching and others aren't, something like that. But I think, yeah, this is not simple, but I definitely see use cases coming up requesting these kind of scenarios.
Do we have other scenarios when sidecars have to be on the same CPU set? Is it often the case? Like, can we like just change the default behavior, or we need to have two separate modes with sidecars and without sidecars?
Practically differs on why sidecars are used. So if you want exclusive CPU allocation, usually it's a process which is doing like the full busy loop. And those processes are usually not really happy if something else start to consume the same CPU cores. So having sidecars on separate, probably shared CPU set is better way. The question is like the whole C groups hierarchy, what is created explicitly, or implicitly because of pod QoS.
So what you're saying is sidecars are always should be separate. So we can just change default definition of policy and exclude sidecars there.
Depends what kind of sidecars are that. Like if it's something like service mesh or some like logger or something, those probably don't need the dedicated resources.
Paco, maybe you have any scenarios in mind when it's the sidecar is actually need resources, need to be on the same resources?
Maybe we come up with explicit use cases and connect them and see. What may happen is if we design for one use case, then we'll get a conflicting use case that wants exactly opposite behavior.
Yeah, for me, it's not one or another. It's just do we need options to have a switch between two behaviors? So we just need to lock on one behavior and have it as default, not configurable. Because I feel that more we discuss this reserved CPUs and sidecars, more I think that it totally makes sense to have sidecars by default, not using the same resources.
Are you thinking of a different parallel hierarchy or just sidecars not contributing to the QoS calculation?
Yeah, not contributed to QoS as a minimal. Like whole separate hierarchy, maybe, I don't know. Okay, what will be the next steps on this?
I feel we probably need to gather these use cases, and so we can generalize and make a design that will cover most of them.
Yeah, probably continuing with issue.
Thank you, Paco, for bringing it in. Kevin, you're next.
Actually, I already processed. I reviewed and yeah.
Oh, it's already done.
Yeah,
Kevin?
and Kevin was not able to attend today.
He pinged me, so I already processed before meeting. Yeah.
Thank you. Ryan?
Yeah, can you give me share access?
You mean making you a co-host so you can present? Or
Yeah,
what you-
please.
It's done.
Yeah, thanks. So I wanted to bring this up to everyone's attention to get everyone thinking about it. I've been testing out the graceful shutdown feature, and I don't think it's working as we expect. So normally, can you guys see my screen? First of all, okay, good. Okay, so normal pod termination usually sends a 30-second grace period for to terminate a pod. And if the pod spec sets a graceful termination period seconds, then that termination grace period is honored during pod termination. And so the kubelet comes around, sees that a pod needs to be terminated, sends the initial SIG term to the pod, waits for that termination, and if the pod hasn't exited yet, sends the SIG kill. That's the normal life cycle for a pod. With graceful shutdown, we intend the pod to be gracefully terminated. And we want static pods, daemon sets, replica sets on this node shutdown via the systemd signal to gracefully terminate the pod. And I included a link to the documentation there for everyone who doesn't know about it. So right now we have two ways of gracefully shutting down a pod. We have priority graceful, which allows a priority class level to be set with some sort of seconds attached to it. The other scenario that we have is a regular graceful shutdown. I'm going to call it regular, where you configure the shutdown grace period and the shutdown grace period critical pods configuration item. That gets set to a maximum period of time to wait. So the problem with this is that all pods during a node graceful shutdown are using a maximum number of seconds to shut down. So if we set the node graceful shutdown to an hour, which is reasonable, we don't ever send a 30-second grace period for the shutdown. And so all pods that do not have a termination grace period set are waiting an hour to be terminated. And this is problematic for a few reasons. OpenShift specifically runs CI with all of its configuration in place. And so we would like to set the node graceful shutdown to an hour, but then have the pod gracefully terminate correctly. And upstream CI is not running the end-to-end test with graceful shutdown on. And so the test pods running in CI would wait an hour to terminate. And so we're getting timeouts on the CI side of things on doing the end-to-end tests when arguably we probably should not. And so I proposed a fix here in this PR that we do send a 30-second shutdown sequence to the pod. This would allow pods to do their normal shutdown sequence. And in the worst case, we set the graceful termination to the group's shutdown grace period seconds. This means that the configuration items that we have for a graceful shutdown, if they were set to an hour, the pod would terminate in either 30 seconds, or if the termination grace period was set on the pod, it would wait that period of time. Or in the worst of cases, it would wait for the entire hour to terminate that pod and finish its reboot. And so this sort of is different than how the feature was originally conceived, I think. But I believe it's correct for how we should go forward with it. I'd like to see this PR go in, and I think we need to improve the end-to-end tests, excuse me, in upstream Kubernetes to enable graceful shutdown so that we can test end-to-end with it as well. Go ahead.
Yeah, I think I'll call out David. I think, David, we probably didn't discuss this, but it makes sense because during a normal shutdown, if nothing is specified, we give it 30. And when this is enabled, we are just not giving the same 30, but whatever the maximum for the group is. So should be uniform.
Yeah, I just wanted to mention, I think, first of all, thank you so much for putting together a presentation and all the info. I think it's super helpful. Yeah, I think when we conceived the feature, we were probably looking and kind of anticipating use cases with much shorter grace periods, like 30-second, like shutdown periods, rather, like 30 seconds or a minute, not necessarily an hour. So I think maybe when you start testing these longer ones, these type of issues come up. And I guess it's just kind of like a behavior question, right? Like if a pod doesn't set a termination grace period, what type of value should you set, right? And I guess there's two options there. You either use the maximum time, which sounds like what we do today, or you just use 30 seconds because it's the default for regular termination. So I think that makes sense. I think like the maybe counter argument to using a longer one is like maybe you would expect the application to be well behaved and exit early, but I guess you can't. It's application specific. So overall, yeah, I'm definitely supportive, I think, of using the 30 seconds. If it doesn't specify anything, it sounds like the right call to align with normal pod termination. Okay, that sounds good. Our use case is that we have some pods that customers are running for firmware updates, and so that's why they need such a long termination period. I see. Yeah, makes sense.
Ryan, thanks for the put this together. Actually, this explains why I saw some production issues and customer complain to me, say, "Oh, I only have the batch jobs, but every time when you upgrade, I have to wait for 1 hour at least." So especially for the large cluster, so the upgrade take forever to customer perspective. I keep suggesting to using grace period, shutdown period, and I said the proper set those kind of things, and then you shouldn't wait this. I think this is explain why, because they have to wait for they always have some pod they didn't cite properly, so they always have to go through 1 hour. So that's why I have the problem. Yeah, this makes sense to me.
Have you seen it with graceful termination, or you've seen it with some kind of upgrade? Because I think a similar issue may happen with any drain scenario when we set override of graceful period.
So I think we'll have to check the code for drain, but I think it should be uniform across all three, like regular, drain, and graceful shutdown.
Yeah.
Yeah, it should be. I think. Okay,
well,
so go ahead.
I'm sorry, I'm just curious. One question I had, when we talk about the defaulting to 30 seconds, where is that done actually today? Is that done on the API server side, or is this done on the kubelet side? Right now, when we talk about that, there's the default 30 seconds if it's not specified.
There is a config item in the API. I don't know if the kubelet does it, or I know that we set the termination grace period in various places. Maybe Peter's on the call and knows for sure if Cryo does it.
Okay, yeah, that'd be interesting because I think
hard-coded. I'm sorry. I'm pretty sure it's a hard-coded field in the kubelet. I think it's documented all over the place, and then Cryo also, at least on Cryo's end, like we also enforce that. Like if it's not, like in cases where it isn't coming directly from the pod, we assume 30 seconds. So I think it's just like a convention that was found.
I don't think Cryo changes it. It's coming from the kubelet, but we need to definitely figure out whether it's the origin is the API or the kubelet.
I don't think Kubernetes set that 30 second. The Kubernetes try to be really conservative. So that's why a lot of places in the old time, even it's like the 4 hour. And so then we introduce 1 hour. So 30 seconds, I don't remember at all.
I think it might be based off of the max wait for container runtime. So like I've seen 30 in a couple of different spots. We definitely like do like there are some places in the kubelet where it's hard coded at 30.
Yeah, the reason I'm asking, I'm just curious because to answer the earlier question, if it's covered for drain scenarios and so forth, right? I think that like depending where it's done, right? Because all the drains will probably go through eviction API, which is on the API server side, right? So if that's done there, then I would imagine the defaulting would also happen. But if it's not, if it's directly via kubelet like graceful shutdown, then we don't have that defaulting, right? So yeah, it would be good to understand that, but we can look at that later offline.
Cool. Yeah, thanks for the review. So I just wanted to bring this to everyone's attention and get some reviews on the PRs and the issue. Thanks.
Ryan, can you take it as an action item to review other drain scenarios to understand that we're not changing behavior in this specific case? Graceful termination is already unique by itself, so we don't want to make it too different.
Right. Yeah, I can do that. And the code here is only in the node graceful shutdown files, but I'll take an action item on the other section. Thanks.
Thank you.
I saw there's one more topic. Rob, do you want to talk about that API things? I keep saw that item on the SIG Node, but never being scheduled.
Oh yeah, sorry. So just real quickly, we have a new KEP that is a follow-up from what we discussed last week. And this is covering a new API in kubelet that would return pod information, specifically readiness information. And just a heads up that it has turned from a doc into a KEP, and we would appreciate any reviews.
Thank you. Yeah, Don, we discussed it last week. I think you missed it last week.
Yeah, I was at the Google Next. Thanks. Yeah.
Okay, last topic we have is follow-up on in-place VPA plus core bindings. I'm not sure who wants to talk about it. Yeah.
Yeah. Here, Jiaxin's here.
Uh-huh.
Right. In the I think 2 or 3 weeks ago, our teammate Ling Yan shared the proposal with the community, and we split some problems into 4 sub issues, and for some of them currently we already create PRs and 1 cap, and we are we try to sync with the community, follow up with the community again on the next steps. Do you think we should have some owners from SIG Node groups, or is just I think have some other process? What's the next steps? Hello.
We probably need an enhancement. I forget like what we said last time. Did we flesh out the doc, or did we say we're gonna work on an enhancement and take it from there? So maybe the doc can be converted to an enhancement and we find owners for it then.
You mean what kind of announcement? Right now we just like move like individual sub issues into a PR or CAP. I think only one currently need a CAP, and the rest we just send out the PRs, and we write the descriptions in the PR and a problem statement in the PR as well. Do you think we need like additional kind of announcement doc or something else?
No, I think for the PRs, it's fine. It should go through the regular review and approvals.
Okay.
And for the announcement is when we'll do maybe planning starting next week. We can discuss it.
Okay, sounds good. So that part is should be done by us or by SIG Node members.
I think Manu, maybe they need it is really next week for the planning. We need to find. Can you summarize what the feature and put in our planning doc once as one item? So we need to find a reviewer and approver for that. But I just want to mention that reviewer and approvers not mean like we agree. Right, so
right, makes sense.
Well, we have to back and forth discussing. If I remember correctly, one of those things I think in last time we discussed, we did explain there's the interesting on that use cases, but the implementation or design might varies, right? So people explain to why CPU manager design like this way, but your use cases is quite real. So we are not just we want more abstract, right, to define, implement that feature in the core system. So, but we can discuss this one and then identify the reviewer and the approver. Yeah.
Okay. So since there's a like kind of important planning meeting next week, if I understand correctly, do you think it's better for us to participate the discussion?
Our planning and design all on the SIG Node.
Oh yeah.
Yeah, but there's the doc. I think you can find from SIG Node meeting here. There's we are using the same doc.
Right.
Yeah, so do this. You put your item there, and your current doc have the several issues, right? So this is why people it's hard for people to digest if they haven't read that before, right? So, but I saw you break into the several PR, and but your proposal, like the single require of the CAP, I didn't see any documentation, just only for that one. So that's a bit difficult for people to digest. So many information.
Okay, no problem. So for the CAP one, we filed the issue and the corresponding PR. Do you think that's enough, or we need a separate a separate doc?
Oh, if you have the issue, then that should be okay. Yeah, I guess.
Right. I gave the issue links in the documentation, and the issue link has the PR associated. Yeah.
Thanks.
And I placed the agenda item for next item, CAP planning. So let's do CAP planning next week. I don't think we will have time for many topics beyond the planning.
Yeah, we can clean up a bit before the meeting next week.
Maybe we should clean up earlier and then share the team earlier so they can add their item.
Yeah, we'll try to. I think Sergey maybe
I know every time there's so many items. I know.
Yeah, if you own a CAP and you have a PR to update it to 129 or anything like that, try to ping on a Slack so we can try. It will be best to have a lot of things cleaned up before the meeting so we will go faster.
Yep.
So if you own something, please send a PR early so we can target it for release. Okay, with that, we reach the end of agenda as it's written. Anything else? If nothing else, thank you, everybody. Have a great rest of your day. Bye.
Right. Thanks.